NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish. The spaceship left the solar system in 2012 and is currently more than 15 billion miles from Earth.
What if our solar system's outer boundary isn't as secure as we thought? Recent findings reveal strange shifts at the Heliopause, hinting at unidentified objects breaching our cosmic barrier. Interstellar Boundary Explorer and Voyager data show the edge of our solar system may be under constant change. Scientists are racing to decode these anomalies, but the implications could shake our understanding of space. Let us dive into the startling evidence and discover what might be approaching when cosmic winds push back. The universe is massive, and compared to its endless stretch, our solar system is just a tiny speck in the grand scheme of things. With snapshots from tools like the James Webb Space Telescope and the far-flung travels of Voyager probes, it is clear how small we really are. But here's the kicker. Recent discoveries suggest that the edge of our solar system, the Heliopause, is acting up in ways no one saw coming. Something unimaginable might already be crossing into our celestial backyard. The Heliopause, for those wondering, is the solar system's outer shell, the boundary where solar winds from the sun push back against interstellar winds. Think of it as a protective bubble that keeps our solar system somewhat shielded. But lately, this bubble has been stretching and shifting in ways that have left scientists scratching their heads. The National Aeronautics and Space Administration's Interstellar Boundary Explorer, or as some call it, the Interstellar Border Explorer, has picked up some wild data. Energetic neutral atoms have been spiking, indicating that the Heliopause is undergoing significant changes. The Voyager 1 and Voyager 2 probes, which are out there past this boundary, have also reported some conflicting data. When they crossed the Heliopause years apart, the differences in their findings were staggering. It is almost as if the boundary decided to move or change its shape between their crossings. These shifts are not just technical anomalies. They are upending what scientists thought they knew about the solar system's edges. Researchers published a detailed study on this in October of the year 2022, highlighting how the Heliopause has changed and what it could mean. They are using every tool at their disposal, including the interstellar mapping and acceleration probe, to try to make sense of it all. But even with all this cutting-edge technology, there is only so much they can do with the data available. The Voyager probes and the James Webb Space Telescope are crucial pieces of this puzzle, but they are just scratching the surface of what is happening out there. To understand what is going on now, it helps to know how we got here. The concept of the Heliopause came into focus in the 1950s. Born from the early days of the space age, once scientists confirmed the existence of the heliosphere, a vast bubble created by the sun's solar winds, they realized there had to be a boundary where these winds met interstellar forces. The Pioneer 10 and Pioneer 11 missions in the 1970s gave us some of the first hard evidence, measuring solar winds and hinting at this mysterious edge. Fast forward to the 1990s, and the Voyager probes delivered more definitive proof. These spacecraft, launched in the 1970s, had instruments capable of detecting changes in solar wind and cosmic rays. By the time Voyager 1 crossed the Heliopause in the year 2012, it sent back unmistakable signs. Solar wind particles dropped off sharply, and galactic cosmic rays spiked. Voyager 2 confirmed this in the year 2018 on a completely different trajectory. These findings were groundbreaking, but they also raised questions about why the Heliopause seems so inconsistent. One theory gaining traction is that the Heliopause is not a uniform boundary, but an asymmetric, ever-changing structure. Picture it as a windsock, constantly fluttering and stretching in response to cosmic forces. Solar wind, interstellar gases, magnetic fields, all these factors collide and create a dynamic, shifting barrier. This could explain why the two Voyager probes, separated by millions of miles, recorded such different data when crossing the same boundary. The shape and behavior of the Heliopause are not just academic concerns. Changes to this boundary could have real consequences for our solar system. The heliosphere acts like a shield, blocking about 70% of the galactic cosmic rays that would otherwise bombard Earth. Without it, the increased radiation could be catastrophic for life as we know it. Imagine Earth's atmosphere being fried like bacon on a skillet. That is the kind of scenario scientists worry about if the heliosphere weakens or collapses entirely. There is also the unsettling possibility that changes in the heliopause could pave the way for something or someone to enter our solar system. While the idea of extraterrestrial visitors might sound like science fiction, scientists cannot rule it out. The heliopause is not just a boundary, it is a gate. If it is shifting or weakening, it could create opportunities for interstellar matter, particles, or even life forms to cross into our territory. The concept of a bow shock, a region just beyond the heliopause where solar winds collide with interstellar medium, adds another layer to this mystery. For years, scientists believed the solar system was moving too slowly through interstellar space to create a true shock wave. Instead, they proposed the idea of a soft bow wave, a gentler interaction zone. But the Interstellar Boundary Explorer mission discovered something unexpected: a bright ribbon-like structure of energetic neutral atoms near the heliopause. No one is quite sure what it means, but it is clear that the heliopause is far more complex than we thought. Some researchers, like those at the Southwest Research Institute, argue that studying our own heliosphere can offer insights into other star systems. Every star likely has its own version of a heliosphere, shaped by its unique environment. By understanding ours, we could unlock secrets about the broader universe. But there is still so much we do not know. For instance, what happens if the heliopause disappears entirely? Could humanity survive without this protective bubble? The heliosphere is not just a barrier, it is a lifesaver. Without it, cosmic rays would bombard Earth unchecked, increasing radiation levels to dangerous extremes. This shield has been silently protecting us for billions of years, but it is not invincible. The shifts and anomalies at the heliopause are a wake-up call, reminding us of how fragile our position in the universe really is. Looking ahead, interstellar travel poses another challenge. The heliopause marks the edge of our solar system, and crossing it is not just a milestone, it is a test. Voyager 1 and 2 proved that spacecraft can survive the journey. But what about living beings? If humans ever venture beyond Mars or the asteroid belt, they will have to contend with the unknowns of interstellar space. The plasma wall at the heliopause could be the first of many hurdles, and we are only beginning to understand its implications. The bright ribbon-like structure of energetic neutral atoms adds to the mystique. These intense bands are brighter than the surrounding areas and indicate activity that does not align with current models. If the heliopause is not symmetrical, it could mean that our solar system is more vulnerable on one side than the other. This asymmetry might also hint at interactions with unseen interstellar forces or structures. The possibility of extraterrestrial influence remains a tantalizing question. While no concrete evidence suggests visitors from another world, the changes in the heliopause raise the stakes. If interstellar winds or particles can breach the boundary, what else might cross into our solar system? The answers to these questions lie in further exploration and better technology. Future missions like the Interstellar Mapping and Acceleration Probe are designed to probe these mysteries. By studying the outer reaches of our solar system, scientists hope to gather enough data to create a comprehensive map of the heliopause and beyond. This information is not just academic, it has practical implications for protecting Earth and planning future interstellar missions. As one story ends, a strange signal draws us to look deeper into the unknown, the silent travelers beyond our solar winds. When it comes to space, the most terrifying discoveries are often the ones that leave us scratching our heads. Take the Voyager spacecraft, for example. These two little machines have been cruising through the cosmos for decades, uncovering secrets that make you wonder if we're really ready to know what's out there. Space, as we've all heard, is full of mysteries. But the stuff Voyager has found, some of it is just plain chilling. First off, let's set the stage. Back in August 1977, the National Aeronautics and Space Administration had big dreams. The moon landing was old news, and they wanted to up the ante. Enter Voyager 1 and Voyager 2, two nearly identical spacecraft with a mission to explore the solar system and beyond. These probes were sent to check out the planets close to Earth, Jupiter, Saturn, Uranus, and Neptune, and give us a front-row seat to their secrets. The idea was simple. Send these machines out for 5 years, collect some data, and call it a day. But here we are, 45 years later, and they're still going strong. Talk about overachievers. Voyager 1 and 2 have had some incredible adventures. Voyager 1 was the first to give us close-up photos of Saturn's rings and its largest moon, Titan. Meanwhile, Voyager 2 went further, swinging by Uranus and Neptune to snap pictures and collect data. It's like these spacecraft just couldn't get enough. Voyager 2 even discovered Uranus's dark rings and magnetic fields, things we didn't even know existed. But here's where things get creepy. As Voyager 1 and 2 ventured farther from Earth, they started sending back some strange signals. Let's talk about Voyager 2 first. By the time it was about 13 light hours away from Earth, yes, light hours, meaning signals take 13 hours to reach it, something odd happened. Suddenly, the data it was transmitting didn't make sense. Conspiracy theorists had a field day. Aliens, they said, had intercepted the spacecraft and were tampering with its systems. The story caught fire when a so-called expert claimed extraterrestrials might be responsible. Even some newspapers got in on the act, throwing in headlines about unidentified flying objects and mysterious glitches. The more down-to-earth explanation? A software bug or some sort of technical glitch. But that's boring, isn't it? The alien theory has a certain flair, and let's face it, people love a good mystery. Imagine if aliens really had tinkered with Voyager 2. Maybe they were trying to send us a message, or maybe they were just curious about the strange object floating into their territory. Either way, it's the kind of story that sticks in your mind. Voyager 1, not to be outdone, also made history. It is the first human-made object to leave the solar system and enter interstellar space. This is the part of space where the sun's influence fades, and you're left floating among the stars. Think about that for a second. This little machine, launched in the 1970s, is now out there exploring a realm we can barely comprehend. And as it drifted farther and farther, its instruments picked up something eerie. Scientists believe it detected the transition from the solar bubble, our sun's protective sphere, to the vast unknown of interstellar space. This boundary, called the Heliopause, is like a cosmic border. Crossing it means entering uncharted territory. Why does this matter? Because understanding what's out there can tell us more about our place in the universe. The Voyager spacecraft have given us a glimpse of what lies beyond our solar system, and it's both exciting and terrifying. They've measured cosmic rays, detected solar wind, and mapped out the magnetic fields at the edge of our solar system. All of this helps scientists understand the environment in interstellar space, which could one day be crucial if humanity ever decides to venture that far. Let's get back to the scary part. One of the most unsettling discoveries from Voyager's journey is the sheer scale of the unknown. These spacecraft have shown us just how vast and empty space can be. Sure, they've found incredible things, like new moons and strange planetary features, but they've also revealed the cold, dark reality of the cosmos. For example, Voyager 2 discovered that Uranus has a temperature of minus 350 degrees Fahrenheit. That's colder than anything we can imagine here on Earth. It's a reminder that space is not just a place of wonder, it's also a harsh, unforgiving environment. Then there's the infamous Golden Record. Both Voyager spacecraft carry a gold-plated disc containing sounds and images meant to represent the diversity of life on Earth. It's like a time capsule for any intelligent beings who might find it. The idea is noble, but let's be real. What if this record ends up in the wrong hands? Imagine some hostile alien race finding it and deciding Earth looks like an easy target. It's a far-fetched scenario, sure, but it's the kind of thing that keeps you up at night. The most haunting aspect of Voyager's mission might be its longevity. These spacecraft are expected to keep transmitting data until their power runs out, which could happen in the next few years. After that, they'll continue drifting through space, silent and alone, for billions of years. They'll outlast humanity and even the Earth itself. That thought is both awe-inspiring and deeply unsettling. These little machines built by humans will become eternal wanderers in the vastness of space. It's a stark reminder of how small and temporary we are in the grand scheme of things. Despite all the questions and fears, the Voyager mission is a testament to human curiosity and ingenuity. It's proof that we're willing to push boundaries, even when we're not sure what lies on the other side. And while some of its discoveries might send shivers down your spine, they also inspire us to keep exploring. After all, the universe is full of mysteries, and the only way to solve them is to keep asking questions and venturing into the unknown. The Voyager spacecraft were not just tools for exploration, but symbols of human determination. Each discovery, from the icy rings of Saturn to the invisible currents of solar wind, has expanded our understanding of what lies beyond our small planet. These two machines have made science fiction feel just a little closer to reality. By showing us both the beauty and the danger of the cosmos, they've reminded us why exploration matters. Consider what it means for a spacecraft to venture into interstellar space. Voyager 1's instruments picked up plasma waves that sound like a faint, eerie hum when translated into audio. This data helps researchers understand the nature of the interstellar medium, the space between stars, and how it interacts with our solar system. It's like listening to the whispers of the universe, a reminder of how much we still have to learn. And yet, for all their accomplishments, the Voyager spacecraft are fragile. Each one relies on a tiny amount of plutonium to power its instruments. As that power source dwindles, scientists have to make tough decisions about which instruments to keep running. Eventually, the Voyagers will go dark, their signals fading into the void. But even then, their journey will continue. These spacecraft will drift through space for millions, perhaps billions of years, carrying their golden records and the story of Earth with them. Just when answers seem near, a single image changes everything we thought we knew. When galaxies drift and physics falters. NASA recently dropped a mind-blowing snapshot of the universe, and it's more than just pretty stars and galaxies. This picture, a mashup of shots from the James Webb and Hubble telescopes, shows us the universe as it looked over 13 billion years ago. That's ancient history, but here's the kicker. Hidden in this photo is a clue to one of the universe's biggest unsolved mysteries. Something weird is going on with how the universe is expanding, and it's all thanks to this mysterious force scientists call dark energy. Dark energy is like the universe's invisible fuel, pushing galaxies apart faster and faster. But here's the head-scratcher. We barely understand it. Scientists have been scratching their heads over this since the late 1990s, when they realized the universe isn't just expanding, but speeding up as it does. This discovery won some researchers a Nobel Prize and left everyone else wondering, how does this work? And this new image might hold the next piece of the puzzle. When you look at this picture, you're not just seeing stars. You're seeing patterns, structures, and spaces between galaxies that tell a story. Scientists are now digging into this image, comparing it to older ones, trying to figure out what's missing in their understanding of how dark energy works. And it's not just small questions they're asking. This could mean rewriting physics books. The problem is that the math doesn't add up. The amount of dark energy needed to explain what we see in the universe doesn't match up with the numbers scientists predict. This gap is called the cosmological constant problem, and it's a big deal. It's like trying to piece together a puzzle where half the pieces are missing, or maybe don't even exist. The more scientists look at this new image, the more they realize how much they don't know. Think about it. If our current ideas about dark energy and gravity are wrong, then everything we think we know about how the universe works is up for grabs. And that's not just some theoretical problem. Dark energy doesn't just shape the universe. It decides the fate of everything in it. Will the universe keep expanding forever, stretching galaxies so far apart that they're swallowed by darkness? Or could it slam on the brakes and reverse course, pulling everything back into one massive crunch? These aren't just wild guesses. They're real possibilities that come with big implications for humanity. Understanding dark energy could change everything, from how we think about time and space to how we approach energy and technology on Earth. Imagine if we could harness whatever it is that's driving the universe's expansion. It might lead to breakthroughs in energy or space travel, things that could let us explore galaxies we can only dream about now. But here's where it gets really wild. This photo might not just tell us about dark energy, it might reveal that our understanding of gravity itself is wrong. Gravity is supposed to be this fundamental force, pulling things together, but what if it's not that simple? Some scientists think there might be particles called gravitons that give gravity its power, and if these particles have mass, it could mean gravity acts differently over huge distances. That could change how we think the universe works. What if ignoring these clues leaves us stuck in the past, using outdated ideas that don't fit the evidence? Missing the truth about dark energy or gravity could mean missing out on huge discoveries, or even making big mistakes about the universe's future. This isn't just a science problem. It's about figuring out whether life as we know it can survive in the universe long term. If dark energy keeps speeding up the universe's expansion, galaxies could drift so far apart that light itself can't travel between them. The cosmos could turn into a cold, dark void. But there's also the opposite possibility. What if dark energy suddenly reverses and everything collapses back into a single point? Either way, the stakes are enormous. Scientists are starting to wonder if dark energy might not be constant after all. Maybe it's changing over time, connected to the fabric of space and time itself. Some even think it might come from tiny fluctuations in the quantum world, the strange microscopic universe that defies common sense. If that's true, then dark energy could be the key to linking quantum mechanics, the science of the very small, with general relativity, the science of the very large. That would be huge. We're talking about solving one of the biggest puzzles in physics. There's another possibility that's just as exciting. What if gravity itself is different than we thought? If those hypothetical gravitons exist and have mass, it could explain why the universe's expansion rate doesn't match predictions. That would shake up physics in a big way and might even lead to technologies we haven't dreamed of yet. Could dark energy link quantum mechanics with relativity or reveal new gravity theories? Share your thoughts, like, comment, and subscribe to explore the universe's biggest mysteries together.